Welcome to Tech It. Have you ever stopped to think about what actually happens when you click connect? It's not magic, you know. Today, we're going to pull back the curtain and map out the invisible architecture that powers our entire digital world. And we're going from your living room all the way to the bottom of the ocean. Okay, so we've all been there, right? Staring at that buffering wheel, asking, why is my connection so slow? Well, the answer might be closer than you think. It's not always your internet provider's fault. A big piece of the puzzle is actually the network you control, right there, inside your own home. And figuring that out, that's the first step to understanding, well, everything else. So here's our game plan. We'll start small with your personal network at home. Then we'll zoom out to see how a whole city gets connected. After that, we're going global. And finally, we'll peek into the future and see what's coming next. All right, let's start at square one. It all begins with your local area network, or what we call a LAN. Think about it. This is the one part of the internet that you actually own and control. Your router, the cables, every single device connected in your home or office, that's your own private digital bubble. And inside that little bubble, you're faced with a big choice. Probably one you make every single day without even thinking about it. Do you go for the rock-solid stability of a wired Ethernet connection, or do you choose the go-anywhere freedom of Wi-Fi? So how much of a difference does it really make? Well, CNET did this really cool experiment right in a regular home. Over Wi-Fi, they were getting download speeds of about 126 megabits per second. I mean, that's not bad, right? You can stream a 4K movie with that, no problem. But what happens when you plug in that little cable? Get this. Just by plugging an Ethernet cable from the exact same router into their computer, that speed jumped to a whopping 395 megabits per second. We're talking more than 3 times faster. That is a huge game-changing difference, especially if you're a gamer or downloading massive files. So you see, it really boils down to a classic trade-off. Ethernet gives you that raw, unfiltered speed, incredible reliability, and better security. Because, hey, it's a physical connection. But Wi-Fi gives us the one thing we just can't seem to live without: pure, unadulterated convenience. Okay, so we've got our homes covered. Now, let's zoom out. Picture an entire city. You've got all these separate LANs, university campuses, government offices, big company headquarters. What happens when they all need to talk to each other with super fast connections? Well, that's when they form something called a Metropolitan Area Network, or a MAN. Now, back in the day, MANs were a really big deal. They were like these essential high-speed bridges connecting LANs across a city, way better than the slow, pricey phone lines they had before. But, technology marches on. As the internet grew up and fiber-optic cables started spreading everywhere, the whole idea of a separate MAN just kind of got absorbed into the bigger picture of the internet itself. And that evolution brings us to the next level up the ladder, the Wide Area Network, or WAN. Now, we're not just talking about connecting a city. A WAN connects networks across entire regions, countries, and even continents. And the biggest, most famous WAN on the planet? Yeah, you're using it right now. It's the internet. And this is where things get really different. Remember how you own your home LAN? Well, with a WAN, it's the total opposite. Nobody owns the internet. Instead, what we're all doing is basically leasing a tiny slice of this gigantic shared infrastructure. It's a massive network of networks, all built and run by telecom giants. I love this quote. The internet isn't in the cloud. It's at the bottom of the ocean. It just perfectly captures a fundamental truth. The global network isn't some magical, abstract cloud floating in the sky. It is a very real, very physical thing. We're talking about a mind-boggling web of fiber-optic cables laid across the ocean floor, carrying trillions of bits of data every single second, physically linking us all together. But here's the thing. When your data is traveling thousands of miles, maybe even across an ocean, just being fast isn't enough. The real challenge becomes quality. Think about all the video calls we do now. For that to work, the connection can't just be fast. It has to be incredibly stable and predictable. So how do engineers even measure something like call quality? Well, they use something called a mean opinion score, or MOS. And check out this data. It shows just how much of a difference the software can make. The technology that compresses your voice, called a codec, is absolutely crucial. You could be on the exact same network, but switching the codec can literally be the difference between a crystal clear conversation and something that's just a garbled mess. So the people who build these networks are basically in a constant war against 2 big enemies, latency and jitter. Latency is just the total delay.
that awkward pause you sometimes get on an international call. Jitter. Jitter is more subtle. It's like an inconsistent rhythm. Imagine your data is sent in little packets. If those packets were musicians in a band, jitter is when the drummer starts playing out of time. It just messes everything up. Taming both of those is the secret to getting that smooth, real-time experience we all demand now.
So what's next? Where does all of this go from here? Well, if you look at the horizon, it's pretty clear our networks are on the verge of getting a whole lot smarter and a whole lot faster. First up, artificial intelligence is completely changing the game. Something called AIOps, that's AI for IT operations, is going to flip network management on its head. Instead of engineers reacting to problems and fixing things after they break, the AI will actually predict issues before they even happen. It'll prevent outages before you even know there was a problem. And while that's happening, wireless tech is making a huge leap forward. You're going to hear a lot more about new standards like Wi-Fi 7 and private 5G networks. These promise to be so fast and have such low latency that, honestly, for most of us, that performance gap between plugging in a cable and using Wi-Fi, it might just disappear completely. And all of this brings us to one final big question. As this invisible architecture that connects us all gets faster, smarter, and more seamless than ever, how is that going to change our very definition of what it means to be connected? Hey, if you found this deep dive interesting and it helped you understand things a bit better, do us a favor and hit that like button and subscribe to Techie. We really want to know what you think, so please drop your questions or your own thoughts down in the comments below. Thanks for watching.